So, can we start? Can you hear me? Can anybody tell me that they can hear me? Yeah, can anybody tell me if they can hear
Good
me?
afternoon, madam.
Good enough. You can hear me, ma'am?
Yes,
Okay,
yes, ma'am.
correct. So tell me, ma'am, when to start. Okay.
Okay, madam. Some 4, 5 students are there. Another 1 or 2 minutes.
Okay.
Madam, you can start, I think. Hello?
Sorry. Can you hear me, ma'am?
Yeah, yes, ma'am.
Okay.
You can
Okay.
start, I think, because many of the students joined as a single group.
Okay. Okay. No issues.
Okay, ma'am.
Okay. Just give me a few seconds, ma'am.
Okay, madam.
Okay, so good afternoon to all of you. Let us start now. So today the topic is all about the computer vision, what we are going to speak. So let me start the PPT. Just give me a few seconds, please. Okay, you all can see the screen now. It is visible.
Yes, ma'am.
Okay. So today the topic will be related to AI, one of the domain of AI, which is the computer vision. And we're going to talk about the computer vision basically on NLP. I have spoken a lot when I was speaking about generative AI. So I'm going to talk about the AI in terms of computer vision. Because when we are talking about AI, the AI has to cover all the aspect of human intelligence. And the aspect of human intelligence involve vision, which is the human vision. So human vision replica is a computer vision. Then you have the human language, the interpretation of what you understand, what you hear, what you speak. That is something called NLP, natural language processing. And the next one is about thinking intelligence, which is about deep learning. And then about the coding and creating a database and deriving information or creating an expert system. And that is about the machine learning. Okay. So let's talk a little bit also about NLP, and then we will go ahead with the computer vision. And we'll also see how the computer vision is some example of computer vision of what is applicable in today's world, how the businesses are using computer vision to create a product and service for enhancing customer experience. So let us look into that. So when we are talking about uh, NLP, which is natural language processing, so one of the main aspect of natural language processing is how do we replicate human language. Human language is a very complex language, and when we transfer this human language in the digital format, 20% of these are structured and rest of the data is unstructured. Like for example, I'm talking about the unstructured data which the company are using for the business purposes are from tweet, from WhatsApp, from social media sites like Instagram or maybe Facebook. And these, it can be in the form of text, it can be in the form of image, it can be in the form of some kind of a language, shortcut language which the customer, which the youngsters use. So all these are something which is a data. And how does a particular, how do we understand? As I was telling you yesterday, sorry, in the previous sessions, that when we talk about the human language, we can take the best example from a baby. When a child is growing, he's around 1 to between 2 years when they start speaking, and they're not very clear. They just pick up on their own certain language and start using certain words which are not very peculiar, which are not very specific to certain objects, and they identify that object with certain names which are not correct. But still, for outsider, it is very difficult to understand a child speaking in certain kind of language which is not a proper or a correct way, the correct vocabulary which I said. So what happens here? That it happens that the mother is the only person who understand, or maybe some are to some extent the father. They understand and they can interpret, understand spoken words, unspoken words. So I'm talking in the terms of when it comes to computer, basically it is the spoken and written language. So when you feed computer with a data which is a human language, in the form of text. Some can be structured, which is very easy to interpret. Some are unstructured. So, natural language processing, which is NLP, is a part of computer science, or AI, which deal with human language, interpreting human language, analyzing, understanding the context. That is where the, because when we talk about certain software which can interpret the written text and come out with a meaningful, summary, then we are not talking about AI. We are talking about AI only when the AI captures the context, understand the way the human being will understand. So NLP is a process, or it's a domain of a AI which try to replicate the human understanding of the language and understanding the way it is so complex and the complexity of that. So this is what about it is. And then we are, when you are talking about the one of the most challenging and revolutionary thing in AI, then that is about understanding the speech, right? Written in text, listening, and understanding. Because listening, if you talk about Alexa, or if you talk about any kind of the smart speakers, or the phone, or something like that, smart assistants, personal assistant, then again one of the format of the language comes into the picture, which is called listening. How do you hear and you interpretate spoken word which can be spoken in different dialect or different way of different accent? So natural language processing is a form of AI that will exactly try to extract the meaning and the context of human language, and ultimately the it leads to the outcome, which is decision making decision, whether the decision is about understanding and agreeing to it, all those things. So this technology is still evolving, students, but there are already many incredible way in which the natural language processing is used today. So we are going to highlight some of the everyday use of natural language processing, and the five amazing example of natural language processing is transforming business. Natural language processing is the ability of computer program to understand human language as it is spoken and written, which is referred as natural language. So it is a component of AI. NLP has existed for more than 50 years and it has root in the field of linguistics. It has variety of real world application in a number of fields, including medical research, search engine, business intelligence. So what I told is we will summarize this. What is NLP? Because this is what we have to clearly define when somebody is asking, okay, what is natural language processing? Why do we use natural language? Why we can't use something else instead? So NLP is an area of research in computer science focusing on processing natural language. And what do you mean by natural language? Is the language which is spoken in any of the language form, not necessarily English. It can be Hindi, it can be a regional language, it can be any kind of a language, it can be German or anything. So now, when we say processing, what do we mean by processing? We mean that we are taking this language and converting them into numbers and that a computer understand. You all know that computer understand one language, which is machine language, and that's a language of binary codes 0 and 1. So computer then perform the several text tasks, such as, what are those tasks which we perform while processing? Processing means carrying out certain kinds of set of steps or tasks, and these tasks are the text classification, text generations, answering the question to demonstrate the answer, understanding. We have seen when communicate with a chatbot on a certain site, let's say banking site, they ask you one question and you give information. They give you certain time, certain option to choose so that they can identify the problem or the issue on which you want to talk. That is called guided, discussion. And then after that, when it comes to unstructured form, in order to understand, they keep on asking you questions till they can understand what you want. Okay. So there is also one term which was given by Andrews Cornell, and that term was called mathematical linguistics. You might have heard about linguistics, which is very related to language. But This is very strange when they spoke about mathematical linguistic, and that is NLP. So NLP is hard from this. If you look at just like the example which I gave you of the child who has who will spend a lot of time to acquire a language, but when we say that a child can always, it is believed that a child pick up the language faster than an adult because their processing, their brain processing for language is very very fast, and it is faster than the adult processing of the language. So it is hard for the adult to learn a language, but it is easy for a child. And that's the reason today in many schools, they put a lot of emphasis on making child learn a lot of language. So you have seen that suppose your child is, your a mother is working and a child is with a maid. And the maid's, whatever language the maid speaks, that is the language the child will pick up. At the same time, whatever language in which the parents are speaking, they will pick up. So most of the parents nowadays believe that we should start speaking in English from the time the child take birth. So they pick up that language. So it is an attempt. NLP is an attempt to model the same phenomena. They're trying to build up a system that deal with the natural language as an input and output. Okay. So these tasks are so hard that even Alan Turing test can't give you a perfect 100% result. Alan Turing test is a test which I told you to test the computer intelligence and compare it with the human intelligence. So finally, the computer science research, one of the researcher also said something which I was reading somewhere and I found it very interesting. So he said that human language is highly ambiguous. It is ever changing and evolving. People are great at producing a language and understanding, but the capability of expressing, perceiving, interpreting, very low grade. So at the same time, while we humans are great user of language, we are also very poor at formally understanding and describing the rule that governs the language. I remember one very funny scene from PK, the movie PK of Amir Khan, where if you understand that, if you remember one scene, those who have seen will relate it with me. There was a scene where, the Amir Khan was interviewed by Anushka Sharma in a jail where they were, imprisoned, and she asked about certain things. And Amir Khan has just picked up a human language which was Bhojpuri, and he was giving a best example of the human complexity in the language. He said that one word will have different meaning the way the word are spoken. So he used the word acha, and he said if you use this word will have a different meaning. If you literally ask what is the meaning of acha in Hindi, it says good. But if it is spoken in a different expression with a different tone, it will have different meaning which the person will understand. So if a person is speaking in a very, he said that okay fine, somebody says acha mujhe samjha raha hai, then other person will say understand, okay fine, acha doesn't mean good here, acha means that he is trying to express his anger in with that particular word. So how do you demonstrate the same understanding of this complexity of the natural language? And that is where the class processing comes. Okay, as I told you that it will take certain processing, has certain steps like classifications of the entire sentence into tokens, then understanding, reviewing the sentence whether it is positive or negative in the form of context. Like I gave you the example of acha, whether the acha said in a good tone, in a positive tone, or does it mean negative? Okay, sometimes anybody is praising you, you may understand whether the person is praising you genuinely or there is some sarcasm, you know. So that is how the people understand. One more example I will give you. When the Maharashtra election was happening, at that time there was a Twitter. There were, I'm talking about, I think 4 5 years back, last Maharashtra election, where Uddhav Thackeray became the chief minister. Before that, there was a lot of debate and lot of conflict in terms of who's going to become CM and which party is going to make the government. And a lot of people on the social networking site were talking about it. So one of the conversation which happened on Twitter, was somebody saying that, Maharashtra election result has become like Amazon placing an order on Amazon and not getting delivery. Now, each e-commerce company, including Amazon, Flipkart, or Snapchat, I don't remember the name, or Mintra, or whatever it is, they have a kind of a social bot, which is called social response bot. The work of the social response bot is to pick up those tweet or those posts or those comments in the social networking site related to the company or the company product. So they are basically developed with an algorithm to recognize those kinds of statements given on the social networking site by anybody which is related to their company. Maybe it's about their product, it is about their services, anything. And then analyzing whether it is positive or negative. So what has happened? Amazon immediately took this particular comment where the person said, and Maharashtra election results are just like the Amazon giving order on Amazon and now getting delivery on time. They took it literally as a kind of a complaint, not realizing the context that it is sent in the context and compared with the election results. It is not a genuine complaint. And immediately the bot replied to the person because that's the role of the bot. The bot replied that we are sorry for the inconvenience caused to you. We'll look into the matter. And this was in the news because a lot of people started saying that, Amazon, such a big IT company, their bots are not intelligent. Intelligence means AI is not there. Then the Amazon started, and every company started feeding the AI, building, integrating the AI algorithm within the bots so that the bot can understand. And that is where the NLP come into picture. Where the NLP, I hope you are understanding what I'm trying to tell you. So it's not about NLP job is not about correcting the English grammatically or accent correcting, understanding the accent of a person that any normal software can do. It is all about summarizing, understanding the context. So I hope I was able to explain you that. So now let us understand the application of NLP before I go to computer vision. So the simple function of the NLP is to facilitate understanding of human language. The following some examples of that I've been going to tell you. So one of the example is about the social media monitoring. Okay. The social media monitoring, just now I told you the example of Amazon and the chatbot. So social response team of all the companies look for the comments which are on the social media about their company, their product, anything related. And they in the chatbot use NLP based tools, which tools the NLP based tools like buffers, which can help them to monitor social media channel, and buffering will help them to buffer and pick up those things where their brand name is mentioned and they get alerted. And when the customer is talking about their brand or anything related to the brand is mentioned, immediately it send an alert, and those kinds of text are picked up, and there is a response to it. And after picking up, what they do is they put it into the tools which is called sentiment analysis. The sentiment analysis categorize the comment as positive. Whether it is a positive, then they say yes, thank you so much for this response, or categorize it as negative where they say okay, there is a problem, we have to address that problem. Or it can be a neutral, so that's called sentiment analysis. You can write a paper actually on that where you can collect this, and you can publish this paper on sentiment analysis. You can take the data which is available freely on the website. Then next is called text classification. Text classification, best example is your Google. So when you are writing a text classification, what happens? You try to search for certain topic. Okay. And when you're trying to search certain topic, is for example in Google search engine, it has a feature called autocomplete. This autocomplete features basically try to complete the sentence. Now you will say that why we need AI in that. We need AI because when you're writing two words at least, It will try to understand what can be the next word. For example, you have written equipment financial and A. Immediately, the related things will come because it has to connect this prediction of the next letter with the previous context. So that is called the autocomplete feature of Google. Sentiment analysis already I have explained you. Okay, so this is one. Then we will also talk about the Google Translate. Okay, so I don't know how many of you have used the Google Translation. The Google Translation also use the NLP, and what it does is basically it try to uh, translate anything which is specially voice command or some grammatical error is there. See, when written text is easy to translate in certain language from English to Hindi, from Hindi to English, or any other language, German or French or anything. But if you are speaking something and your accent is not correct, there's a grammatical mistake in your sentence format. There it uses the NLP. It uses something called text classification and short out the topic, filter the topic, do this, everything it is doing like that. Okay? So that is where we are using this. Then we have something called target. Also, NLP is used in target marketing, target advertisement. The online advertisement, the ad which you see is based on your online activities, whatever you are searching. You get an ad related to those which start following you. So most of the online company today uses the approach where the company save a lot of money, and NLP helps in targeting advertisement called techniques called keyword matching. Email categorization. Gmail uses NLP especially to group the email we receive, and these are categorized into three tabs. If you look into, I don't know how many of you paid attention on your Gmail. If you have not paid, you can check it today. There are three categories of mail which they have put a three tabs. One is primary, second is social, and third is promotions. All your personal mails which is in your contact list will go into your primary notification, and all the mails from the social media like from LinkedIn, from Facebook, or from Instagram will go into social tab, and the newsletter from the companies about the promotions or anything related to that will go into your promotion tab. So they use NLP to identify and evaluate the content of the email and then categorize them accurately. So this is the one thing of the NLP. Okay. So let us look into some more application of NLP. Then I'll go into the main topic of today, which is computer vision. So when you're talking about NLP students, what some more example of in our day-to-day life is email filtering. Email is something which we always it's a become a part and parcel of our life, and we get piles and piles of spam mail and a lot of other mails which comes from various sources. There will be mail from work, there will be mail from school, there will be mail from e-commerce site, there will be promotional mail, so many things. Just like that, I told you that how NLP try to categorize those mail not only as a primary social or promotional mail, but also as important and recognize certain mail depending on the characteristic as spam mail. Nowadays, they also give you a notification where they say that this mail is not from your organization, from external organization, and do you want to trust this? So they give you, a warning. Then when you are writing a mail at that time, also while writing your mail, they auto complete and they give you prediction. For example, if you've written Sheetal at certain organization.com, for example, and when you're saying dear, automatically it comes as Sheetal. So this is something which they have integrated in the form of an LP. Language translation, already I told you that how language translation happens. NLP helps in processing of translating your language along with the context of it. Smart assistant, today we see a lot of smart assistant devices which we are using like Alexa, Siri, Cortana. All these are using which can talk to you like a normal human being and respond to you in the same way the human being can do. This is all possible because of NLP. Okay. The next thing is about document analysis. The document analysis, another one NLP education is document analysis. Like for the companies, colleges, schools, and other places, they have a lot of data which comes, lot of documents which come. This can be done using NLP. So it's not only searching the keyword, but it is also categorizing it. Okay. Then we have online search. Online, this lot of puzzles, lot of challenges. So how do we have one of the most extensive resources on the internet is about searching and finding the correct information. So already I have spoken about how NLP help you in searching the relevant information in less time without wasting your time in a short period of time. Trying to do that predictive test. Predictive means what is going to come next, which is the application of online search like Google and all. So whatever you are writing, it is trying to, even in the smartphone also. You might have seen in the WhatsApp also it is coming now, or even Apple phones and all. You have suggestion of the next word. What can be the next word? Depending on what you are writing, the previous text. So this is how it is getting trained according to your text and according to the data which is being used to train that particular AI model, it suggests you the next word. Okay. Then summarization. You can put all the entire document and you can summarize it into a small form. The man, which is the NLP has a solution to summarize something in a very simple language for you. The medical data and follow example like that. Sentiment analysis also I told you. Chatbots also I told you how it reply by giving you an example of that. Social media monitoring also I told you about this. So these are some examples you can keep it in mind. Alexa, sentiment analysis about neutral, positive, negative feedback. Then translation, how you can translate certain things which are not written perfectly. Okay. So prediction of the next word, to complete. So these are certain components. I'll just not going to briefly describe, but I'll tell you because this is important for you to develop any solution with NLP to understand the concept of NLP. There are two components of NLP. The first, sentence segmentation. Sentence segment is the first step for building the NLP pipeline. It breaks the paragraph into separate sentences first. Okay, so you can consider this example, and you can see here is this in this particular example, the comprehension mess, the nightmare, the classy. All these are, you can see each is into broken into the entire paragraph is broken into two paragraphs. Okay, and then the second step is tokenization. If you can see that each word is highlighted into different color, which is called token. So word tokenization breaks sentence into separate word. So the first is sentence segmentation, second is word tokenization, and then, so when you're seeing this, you can see the tokenization as such is one word, mess is one word, stuck is one word, nightmare. All these are tokens. These are called token. Then the third thing comes. So this is how the token comes. The third thing comes is called a stemming. Stemming means finding the root word of the word. For example, if you say playing, plays, and played, the root word is play. So stemming is a process of producing the root word from where the word other word is derived. Okay. Like for example, am, are is the root word is be. Car, cars, all these different form is car. The fourth process is called lamentization. So stemming is finding the root word. Lamentization is similar to stemming. It is used to group different form of the word into something called lemma. And main difference, it will look same as stemming, finding the root word. Ultimately, you can see here drive, drives, drove, driven. The lemmatization is drive. Then what is the difference? The difference between stemming and lemmatization is that it produces the root word which has a meaning. Okay. In lemmatization, the word intelligence, intelligent and energy has a root word intelligent, which has a meaning. So root word doesn't or normally come at stemming doesn't come out with a word ultimately which has a meaning, but lamentaization does that. Then the fifth step is identifying the stop word. That means where is a paragraph ending? The stop word can be filtered through statistical analysis. Some statistical analysis tools are used. For example, you are writing, he is a good boy. So, why, if you look at the sentence, normally a human being will look at the full stop, comma, or punctuation mark to basically find out whether where the sentence is ending. But for computer, these punctuation doesn't work. So they have to use a stop word to understand. So they basically create a stop word segmentation. Okay. So there are so many things which are happening. So this is the stop word segmentation. So I'll just go ahead. I'm going to now show you an example before I go for something to make you understand something like how artificial intelligence is growing faster, how technology is not remaining as a piece of software, but it is trained by data. So, one example of that I'm going to give you now. Before that, I will make you understand what I'm trying to give you. So, I will be using one of the tool of Google, which has AI, which is called Quick Draw with Google.com. This particular piece of the software is trained in the form of number images. Like as I told you that all the AI is trained either with different forms of data. It can be a numerical data, it can be image data, it can be sound, it can be text data. And from this data, the AI learn the pattern in the data and make prediction to solve the problem. So AI is basically the purpose of AI is to solve the problem by using historical data and do prediction. Okay. So, for example, a self-driving car, I'm going to give you example of that. How does a self-driving car decide to stop or speed up? It is all based on AI prediction, which is trained on the basis of historical data and which automate this stopping and moving in certain direction. Okay. So, similarly, way the facial recognition system, which identify you to open your phone screen, they also use the AI prediction method. So AI predict based on historical data, they identify a pattern and predict what comes and predict whether it is something like that I'm going to show you. Even if you can see the prediction in the spam filter, in the social media feed, in e-commerce recommendation. Okay. All these are called things. So uh, when I'm talking about this example is an example of AI neural network, which can recognize a doodle which I'm going to draw and which is again whatever I'm going to draw, it will try to identify that because it is being trained by maybe by feeding millions of data. So this is a doodle where millions of data is feeded, image data is feeded to make it recognize a particular picture and label it. So I'm going to just without wasting time, I'm going to do that. Just give me a few seconds. Okay, I'm just going to share now with you. Okay. So can you all see now? So you can see now there is a site which I have gone. This is a quick draw with google.com. This particular example I am giving you to make you understand that how neural word network learn from historical data and identify a similar pattern and try to predict what it is. So it is recognizing something which you are doing. So let's say I'm going to try. It's a biggest, largest doodling data set it has. So I'm going to draw. So I'll go to here. It's now it is giving me draw a lighthouse in under 20 seconds. So I'll say okay, got it. And I'm going to now draw the lighthouse. So you can see that what it is saying. See that? So it has asked me to draw the. So if you can hear it, it said that it is not able to understand what. Now it's saying asking me to draw a belt. Let me try something good. Okay. So it is giving me instruction also. See here, see here. So I could draw it well. So it says it is belt now. Now it is asking me to draw a baseball bat. I'm going to do that. So I didn't draw it well. So it's not able to understand the pattern. So now bridge. So let me see if I can draw some. So it is again not drawn well. Okay, mosquitoes. Let me try my drawing skill. So I was not, so it is not resembling a. Okay, let me try this. See, so I could draw it well. So these are the 6 examples which I have done. It asked me to draw a lighthouse. I was not able to do it. It is wrong. Belt, because it was looking like a belt, so it could recognize. I'm going to show you how it does. Okay. So let me click on this. So now understand students what I'm trying to explain you. I was asked to draw a lighthouse. Okay. I draw a lighthouse which was not similar to what it should look. It didn't recognize it as a lighthouse. So the closest match is this. This is what is feeded into it. That lighthouse can look like this. You can see here numerous data of lighthouse. You know, and this is not perfect. This is all imperfect, but it should have some common pattern. It recognizes that all these have common. See, this is not so clear, but then still it can recognize it as. So if I would have drawn any figure of lighthouse which is matching with any of this, it would have recognized. I'll just go back and show you the one which have. See, belt. The neural network has recognized because when it goes into the data, it has all these data. And the data which I have is matching with this particular thing. If you can see here, this is matching with this. And the first attempt was like it tried to identify like this. So this is how the doodle work. Again, I will show you one more example. Okay, mosquitoes. So it looked like an ant. It told me it is a ship because the closest match was the ship. Then the second thing which when I draw this, it matched with an ant. Then turtle. But actually, this is how, if I would have drawn something near to this, it could have matched the picture with any of this, which is also a rough picture, not very clear, and could have recognized it well. So, what I mean to tell you is that when you feed a computer system, train it with a volume of data, historical data related to something, it can be an image data or anything, it try to establish a pattern into it. And with that pattern, it tried to predict the next input which comes to it. So the input is this from my side. And from this input, it tried to match it with the closest match, second closest match, and third. Ultimately, it asked me to draw mosquito, which it was not. So it could not identify it. Okay. So it said that it is not able to recognize. I'll show you the correct one this ways. So you can say that first time when I have drawn the base, it is a correct match. This is the second closest match, which says it can be an owl because that also look like that, or it can be an alarm clock. These are the data which was fed to train the model. These are all data that it can be closest to any of this. So my picture, if you see, is closest to this. And that's how it could recognize that it is a vase. And it says that it has recognized. So any questions so far, students? No? So let's go back to our slide. Okay, I'll share it. Okay, fine. So I spoke about all these things. I'll give you some example now. I was talking now, I've started talking about computer vision. Okay. I gave you some demo. So the lesson which we have learned from this particular demo, the Doodle AI, is that the learning of AI is can be altered over the time. It will not remain fixed. That's the beauty of AI. So AI you interacted with here is a production version of AI which is called inference AI. Inference AI means inferring something out of the picture, image data. So training AI is what is trained by the data scientist within your house data. The in-house data I have shown you for all the pictures which I have drawn. So 80% of the available data is used to train the model. 20% is used to test it, the accuracy of prediction. So this can be done in many ways by adding to the training data. So inference AI is when AI is ready for production, ready to meet the customer. So the customer simply uses the connected, you know, product, and this is similar to training the AI. I'm so sorry. I'm saying customers and all. Sorry, I was looking into something else and talking. Okay, so every time you interact with an AI on your phone, or you look at the camera, or you are using any kind of a software, you are engaging with inference AI most of the time. Okay, so this is also in a way we can call it learning AI, which learn on its own. Which say machine learning, that means learning on its own. So AI continue to learn from the data, and that becomes a new training data for it, and it becomes more smarter day by this. So there is no fixed data which is there. So you feed of historical data which help you to identify, but whenever there is a new data, it try to accommodate that and learn from that, and it create a next version of it. Okay, for which of the inference AI. So Doodle AI learning from Doodle, which I just showed you, it is a learning AI, and the thing is that it is learning live from the Doodle. Live. That is also very important. One is the historical data, one is learning live from the doodles, which we are making. So this is the capability of capability of the computer or the AI to learn live is also new concept in computer NLP, or you can say in computer vision. Okay, so I'm going to just show you how it is used in different organization. How do we apply that? We can apply that in production. I'll give you example of all these things. In production, we can apply. We may have historical data fed into one particular software, which will train the AI model to recognize, let's say, some fault in the machine. But let's say the new fault has emerged, which will have some similarity with the historical data. but it is totally new data. So what happens? This will take the new data will be taken and it will infer that there is a kind of a fault. It will recognize the fault. Okay. As I said that it will all these things I said that it will have a question of yes and no. Inferences whether it is like what I did with you. I showed you the demo in which the computer just like us will think like I have they asked me to draw a belt. When I draw a belt, whether it is a belt or not, there's an answer, yes or no. So the computer like us will answer. Well, yes, it is a belt. No, it is not a belt. So this is what I have shown you already, students. This is also used in smart city by for identifying the temperature, for identifying the precipitation level, the pollution level, which is a talk of the media today for Delhi and all these things, which is certain kinds of sensors responding and communicating with each other, interacting with data. So all this is what I have already told you. Okay. So now we will also try to understand the concept of computer vision, the next domain of the AI. So computer collects images or video data, right? There are a lot of IoT cameras also, which is maybe there in your house. It can be there in the traffic junction. These cameras can watch for traffic violation. They can be camera that will help your autonomous vehicle drive. So let us look at this particular type of AI where the AI is not trained using text and word, which if it is trained using text and word, we have NLP to analyze that. But it is trained using some kind of a image data or video data, right? So how do we train the computer to infer or interpret the image or video data? Okay. So till now I was talking about the NLP which deals with words or any of the data which comes in the form of numbers, text, spoken word, spoken, human language and all these kinds, written or spoken words. So there where we are using the NLP. But when we are talking about image data, which is caught through camera with sensors or which captures the image and send for traffic congestion, traffic violation, what do we use? The IoT sensors, which are also recording certain data. So we're going to talk about computer vision. So just a minute, give me some time. So when we talk about computer vision is the AI that can understand visual image or the AI is trained using visual image or the videos. Okay, that is called the computer vision. So let us learn some common model which is involved in computer vision. Uh, let's say from connected camera or whatever data from wherever we are going. Okay, so the computer vision is is trained just like how NLP or the computer is trained using NLP. That is your words and text and all those things, text data. So here also AI is trained by label image. The word label is very important here. I've already shown you one demo of from one particular site on no code AI when I was teaching. So AI is trained by label image. Again, it is also called the inference AI. So let's say when a customer is interacting with a kind of a model, the new images are actually generated. So computer vision models can detect object, classify, group them, extract a pattern from them, and use machine learning algorithm or neural network to combine it with a deep learning to come up with some inference. So computer vision model can detect an object such as person crossing the road, okay, from the crossing the road in front of the car. It can be an object detection, okay. It can be the object which are labeled in the training data, and the model learned to identify and detect this object from the labeled data. The computer vision model can classify things as different classes or objects, like for example, men, animal, non-living things, stones. It can do that. It can predict a pattern in the object, like for example, object detection. It can always do that in the signals in the Europe or even in the UK also you can find some traffic junctions which has these camera with kind of a sensor, and also the it is connected. So the software it is connected with the cloud platform where you have an application, and this application whenever the image is collected try to identify whether the what kind of object it is, okay, and classify them into different class of object. That is also called the object classification. So computer vision model is used to also to count objects in the factory, not only identifying, but maybe you can count the production, how many product, what is the volume of the product which is being created. For example, a biscuit manufacturing company will use the computer vision model to identify the shape of the biscuit has come into a proper shape or not. For example, let's say Parle. So they will identify whether all the biscuit is rectangular, whether the logo which should be imprinted on the food on the biscuit is properly done or not, whether it is blurred or not, and they try to reject those kind of biscuits which are not in a proper shape or proper format. What this is. So the computer vision model can detect a pattern in the video for motion detection in security cameras. This can also be done to detect the videos, images. So computer vision can do a lot of things, but the vision data has to be labeled. So you go back to that particular session, students, where I have shown you uh, one example. If I will just go through that example again. If you remember the example, in this particular example, what I have done, I will take you through this example again, where a tire manufacturing company want to identify whether the tire has some defect or not before sending it to the supplier, because they don't want return, you know. So what they do is they have a lot of pictures of defective tires as an historical data which they have input and labeled it as a defective tire. Then they have a set of pictures, set of a data which has a image of all the good tires, how it should look. And with these two, one category good tire, one category defective tire, they feed it into computer and trained. Now you put a new tire. Whenever there is a new tire, the camera catches the images of the new tire product and put send that to the application. The application which is trained on two label data, defective and good tire, try to match the pattern whether the pattern matches with the good data or defective tire, and then do the inference, which I will show you again today. Okay, so this is how the computer vision model extract the knowledge or information from the pattern of the image, okay, and try to identify that. Okay. So this is in the traffic junction in the China and in Europe they use this, where they have a camera with sensors and a camera with certain software uh, connected with networking with certain software on the cloud. And what happens? They take the picture of a particular person, and from the picture they try to identify from the database that whether that picture is matching to some criminal or not. Okay, so that is a facial recognition system. So the face may change, maybe the hair color may change, the hairstyle may change, the the size of the person, or maybe he has gone he might have changed the style of his beard or something like that may change. So basically what it does, it takes the picture from the camera goes into the application, and the application try to match it with the database of the criminals, and then sent an alert to the nearby police station. So this is one example of that. Okay. So extracting information from the image is something which we were calling as computer vision model. And most of these image are, and this kind of, they use a technique of AI which is unsupervised, also deep learning, because computer vision is mostly associated with deep learning. because deep learning comes into picture when you have unstructured data. Okay, so this is already I told you how they can recognize. The first recognition is whether it is a female or male, what is the color of the hair, what is the kind of the facial structure, and what they are carrying, and depending on that they try to match it, and they try to conclude. Even if the matching is not 100%, they can conclude it. This is also somewhere called the convolution neural network, CNN. Okay, this is how the camera work. If you can see that all the people, even from the back and from the front, so there will be a front camera, and this, so you can see this person is facing the camera. So there will be some camera here which will be have the facial uh, picture taken, and from the back also they take the picture from front and try to match it, and try to find out even if it is not accurate match. Okay, this is how the matching happens. So let's say this particular person who has changed his look. He in the database his picture doesn't have a glass. He doesn't have a beard, which he's wearing now. His face has become little plump. Maybe the face was very slim. So you can say this is the actual picture of this person which is in the database. But when this picture image is caught by the camera, though he's wearing a glasses over here, and so how does it recognize and give a 100% prediction? This is on the basis of computer vision model. So they identify a pattern. They make a three-dimensional pattern of the space. Similarly, the way the facial recognition work. I'll give you one more example here, students. So let us understand how Google driverless car work. In order to understand a Google driverless car, how does it work perfectly, which is called YMO. And I will take you to the Google website also, show you some video. But before that, let us understand the technology behind this. So technology has two aspects, hardware and software. The hardware part of it are all sensors in the car and the cameras. So the Google has many sensors. They have sensors on the side, all sides of the car. They have radar sensor here in front of the car. The radar sensor will reflect the light which is 60 meter ahead of the car to identify any kind of obstacle in front, which includes even the road blockers. Okay, they have a video camera on the front of the car. This video camera monitor the vehicle surrounding again for any obstacle, for anybody passing, crossing the road, and all these things. Then they have a lidar which has a 360-degree view. This lidar is called light detection and ranging, and this moves and gives a 360 view of 60 meters on all surrounding of the car, left, right, front, and back. Then they have sensors on the door. They have odometry sensors on the tire, which is trying to measure the distance between the tire and the adjacent car tires. The adjacent obstacle, maybe it can be a pedestal, it can be a nearby tire on all the sides. On all tire, they have position estimators and distance estimator sensors. Then they have ultrasound sensors also. They have GPS, which try to identify the location and give the position. So, in short, or in summarization, you have this hardware sensor, which is radar, video camera, position estimators, infrared lamp. Then you have stability control. In software, the driver of the car is artificial intelligence, AI. It takes the data from all the sensors. It takes the data from GPS, from so many things, the traffic report and everything, and it take a decision. Decisions of how a human driver will take. When you drive a car, you take a decision to slow down a car, put a brake on the car, stop the car at traffic junctions, uh, change the lane, speed up, accelerate the car, slow down the speed, change the lane. All these kinds of decisions are taken because you have your all five senses and IoT as a sensor. Your sense organ, you see from your eye, you see back, front, from the mirror, you see, you hear the sound of the object nearby you, and you understand and you take a decision to do all these kinds of things. So let us go to the Google site and see how it works. Okay, can you see now? Okay. So this is a Google project which they started in 2008. It's called Waymo Driver. And the objective of this particular project was to reduce the number of accidents which happens because of the human error. You all have known that most of the accidents on the road happen because of drunk driving, careless driving, carelessness, or maybe somebody else's fault. And this is something which the director of the Google, Sebastian, his name, first name I don't remember, but you can always go ahead and you can see one of the TEDx speech if you get time. It is very good. It's available on YouTube. And he came up with this when he lost his friend in an accident. And he thought of this and he started this division because if you see, Google is all together into search engine and other products which are service related. But they have to come out with a product which is a product which is not service because they were in the service industry, they have to come into product. And they came into this product which was very successful. From 2014 onwards, this Google Drive car, Waymo car is driving on the roads. There are four places where it is driving. If you want, I can show you. These are the places where these cars are run successfully: San Francisco, Los Angeles, Phoenix, and Austin. And it is also called auto taxi. Now, most of the companies have taken this car. Like Uber in Petersburg is using 100 autonomous vehicle. So Waymo car, if you see, it looks like this. Initially, the shape, the car has a different picture. Now you can see here how it drives. You can see here. So I'm just going to take you through one video first. So this is a fully autonomous car and it avoid this particular problem of accident because of drunk, tiredness and distraction. I'll show you this now.
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software, which allows it to move through the city on its own.
That's correct. The Waymo driver is a combination of custom-designed hardware and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense, solve, and go. It's the way we describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
So if you can see here, it says that the entire technology of the driving goes into 3 steps: sense, solve, and go. Sensing means sensing the environment around you. And then is the solving the problem. And this sensing happens because of the sensors. So it's going to explain how it is sensing.
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3.
So you can see this is a LiDAR on the top which is rotating. Then it has a camera in the front which you can see on this windscreen. Then it has sensors on the tires and it has sensors on the back and in the front. Okay, and this can, you can see that green radar sensor which is reflecting the radar light on 60 meters surrounding the car, which can take the image of all. This is one example of the computer vision and also the data, the IoT sensors. So it takes the image also, the camera takes the image of surrounding, nearby car, obstacles, anything. Car, a particular animal crossing the car, in front of the car, everything. And that computer vision will interpret that image as whether this image, because it has been fed with lot of image, so it can recognize the object, whether it is a object, it is a signal, or is it a animal crossing, or what it is, and then take an action. So let us see how sensors work. The first one.
Football fields in any direction and can detect sirens from emergency vehicles, which allows the Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene.
So you can see what it does. It's saying that it is taking the sensors and the camera is collecting all the data. And that is called sensing the environment around the car. But what are they going to do with that data? That comes the second step, which is called solve. So with this data, for example, if they see a data of two people cycling, now what a particular human driver will do? Try to relate, students. When just a minute, just a minute. So students, I'm going to play this video for you because I have to just go for a small meeting. Harinakshi ma'am, are you there? Can you hear me? Harinakshi ma'am?
Madam, 1 minute, madam.
Yeah,
Yes, madam.
yeah. So I'm going to just play this video and go. I have
Okay.
just a small meeting, okay?
Okay.
In
Okay.
case if I come back, I'll just try to come back fast. If I'm
Okay.
going to take time and I'm not coming, maybe you
Okay.
end up the meeting. What I will do is in the next session, I will complete this.
Okay, madam.
Because it's just an emergency meeting which has been
Okay.
called for.
Okay.
Ma'am, I'll just
Okay, madam.
run this video. You
Okay.
see, by 2:30, if I don't come, you end the meeting. Okay?
Okay, madam. Thank you.
So much emerging technology is just a show. So one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors.
Madam, no video, only subheadings are coming.
Technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense,
So much emerging technology is just a show. So one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
That was Shweta Shrivastava, Senior Product Lead for Driving Behavior at Waymo.
What you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal vehicles. Take this Jaguar I-Pace, for example. It's been equipped with an elegant array of sensors and software, which allows it to move through the city on its own.
That's correct. The Waymo driver is a combination of custom-designed hardware and software that is responsible for performing the entire act of driving.
That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more.
The Waymo driver handles the task of driving in 3 basic steps: sense, solve, and go. It's the way we describe the highly complex process of acquiring information, processing it, and moving through the world safely.
So, what goes into all that sensing?
The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, cameras, and radar. It can see up to 3 football fields in any direction and can detect sirens from emergency vehicles, which allows the Waymo driver to visualize the world around it in milliseconds to a high degree of accuracy.
Okay, sense makes sense. But what do you do with all that data?
Good question. The system calculates the predicted future behavior for each relevant agent in the scene. Then, with a strong foundation derived from artificial intelligence and machine learning algorithms, the Waymo driver crunches all that data and calculates a safe route, while responding in real time to the evolving traffic environment.
If I understand correctly, this means the Waymo driver continues to learn as it goes, is trained and tested on scenarios that it's never seen before, and can differentiate safe and comfortable driving behaviors from hazardous and uncomfortable ones.
Yes, well done.
Why, thank you. The final step in the Sense, Solve, Go methodology is perhaps the most straightforward. Go.
Once the Waymo driver has determined the path to take, our advanced motion control systems allow for smooth acceleration and braking on hilly streets, or managing bumper-to-bumper traffic with safe and natural driving movements.
So it's really here, right now in cities. Not smoke and mirrors, but true autonomous driving technology. Waymo is taking what was once futuristic sci-fi and making it non-fiction. And like all great technology, all that number crunching, all that data just fades into the background. And you realize the dream of riding in a fully autonomous vehicle to your favorite dinner spot isn't just a vision of the future. It's actually happening right now.
Hello, students. I am ending the session because madam has gone for emergency meeting. Tomorrow next class she will continue the. Hello. Hello, respond.